In this lesson, we'll work on adding squash and stretch to the Flexi Line. So here's how squash and stretch works. What we'll need to do is find the length of our system and divide that length by the change of our length. So as that length starts to either increase or decrease, that's what we need to divide by. And that will give us volume when we start to transform our connect curves. We don't have to worry about the y-axis because we already have a stretch and a squash in that axis. So we just need to be concerned with what happens in the other two axes. Alright, so let's go ahead and get started. We're going to be adding this to helpers D, C, and B. On A and E, they should not squash or stretch, simply because those are the anchors. We want that to happen right in the center so we can keep volume. We'll also make sure that helpers D and B do not squash and stretch as much as C would. We're going to get more of that result from the center. Alright, so this is going to look really cool by the end of it, but the first thing we'll want to do is go ahead and move over to our motion panel so we can assign an X, Y, and Z controller to our scale controller. That way we can apply the expression that we're about to create to the axes that need the expression applied. Alright, so with the scale selected, I'm working on D right now. Let's head over to Assign Controller, and we will assign the scale XYZ. Alright, great. Let's go ahead and do the same thing for C. Again, just select Scale, find XYZ, and apply. And then finally, we'll do this for B. Alright, great. So once that's taken care of, we'll do the same thing for our global control. The reason why is we want the global scale to influence the scale of the helpers that will squash and stretch. That way, we can always make sure that this scales relatively. If we don't consider the global control scale, we're going to notice that the squash and stretch will not work because the system doesn't know to look at the scale of the global node. So we need to tell it to do that. Alright, so with the global control selected, let's go ahead and find its scale controller and do the same thing. We'll apply the XYZ here. Alright, great. So now that that's done, now what we need to do is work with an expose node so we can find the distance we need to plug into our equation. We don't need to find the distance of the entire chain, only the distance between objects that will change. So what that means is we can actually go ahead and find the distance of D and B, and that will cause our squash and stretch to work just fine. Because you'll notice if we were to go ahead and grab the bend control, for example, and start to pull that around, you can see eventually that distance is going to change. So this is exactly what we need here. Alright, so let's go ahead and create our expose node. Right over to the Create panel. Underneath Helpers, we'll find our expose node. There it is. I'll press the S key so we can snap it right to the center of our scene. We'll right-click to exit our helper mode. From there, we'll go ahead and press the S key to disable snapping. Let's head over to our Modify panel. We're going to go ahead and change the display of this object so we can work with this a little bit easier. So instead of a cross, let's go ahead and work with an axis tripod. And instead of a size of 20, which is pretty large, let's go ahead and drop this down to about 4. Alright, great. Now, since this is going to help us find the distance we need, we're going to go ahead and rename this to Flexi underscore distance 01. Alright, perfect. Let's go ahead and make sure that this is linked to our group object. So I'll actually go ahead and link that to the global node simply because we just want that to follow along. It's not going to change how the squash and stretch will work. We'll still be able to plug in the information we need, whether this is linked to the global node or not. But just for convenience, it'd be nice to just have this follow. Alright, great. So going back to our expose node, let's go ahead and head over to our Modify panel, and let's go ahead and take a look at some of the information we have. So notice we can expose a few objects here. Let's turn off parent, because we don't want to consider the parent at all. We're looking at two unique objects that aren't necessarily linked together. All right, so we'll go ahead and turn off parent. Let's go ahead and expose anchor B, and we'll also expose anchor D. All right, great. So watch this. If we were to scroll down, notice we now have the distance between the two objects, and that distance is 10. So here's the value we need to divide by. It's going to be 10 divided by the change of this value of 10. All right, perfect. And again, we do need to consider the global node scale. So we are actually ready to create our expression. Let's go ahead and start with BN_DRVB. All right, this is what will scale. So with that selected, we'll head over to our motion panel, and we're going to go ahead and apply this to the X and the Z. Remember, the Y is already taken care of. We're already getting squashing and stretching in that direction. So let's start with the X. With that selected, we will now apply a float expression. All right, let's go ahead and create a few variables. The first one is going to be length, and we'll tie the distance between those two objects to this variable. The next one is going to be global. So this is for our global scale. All right, great. So to assign these, let's go ahead and start with the global node. We'll simply choose Assign Controller, expand objects. Here's the global object. Let's go ahead and expand the inside so we can get to its scale Y. I'd like to point out that we can use any one of these controllers. I just like to stick with Y for some reason. But let's go ahead and use Y. We'll choose OK. All right, from there we can go to the length, and we'll choose Assign to Controller. Remember, we have parented the expose node to our global node here. So we'll need to expand the outside of the global node, and we should be able to find Flexi Distance. Here it is, right at the bottom. We'll expand that, expand Object, and we'll need to go ahead and find the Distance channel, and here it is. All right, so with that selected, we'll now choose OK, and we're ready to go ahead and type in our expression, and that will be as follows. That's going to be 10. Remember, that's the length that we found by using the expose node. Now, in order for this equation to consider our global node, we'll need to multiply this 10 by global. All right, great. So now we need to divide by the change of that distance, which we have tied to the length variable. So we'll go ahead and name that length. We'll add that to our expression. Beautiful. So it's as simple as that. We can go ahead and evaluate this. Notice everything works properly. Great. Let's go ahead and highlight this line of code. I'll go ahead and just copy that. And we'll use that for the scale Z here. So we'll go ahead and assign another float controller, float expression controller. We'll go ahead and paste our equation in. Again, we'll type in global as a variable. We'll also type in length as a variable. Let's go ahead and assign our controllers. So for length, we'll go ahead and find the distance. There it is. And for global, we'll go ahead and find the global scale Y. All right, we'll evaluate this and test it out. Let's go ahead and close out the expression editor. We'll go ahead and create, let's say, a box. All right, from there, I'll head over to the hierarchy panel. We'll go ahead and center the pivot on this box. We're just testing this out. Let's go ahead and use our quick align tool with Shift A and align this to BN_DRVB. From there, we'll just simply go ahead and link to that object. All right, so watch this. Now when we grab the connect curve and we start to pull that around, you'll notice that our box is actually going to start squashing and stretching. How exciting is that? Now, remember, we don't want B and D to squash and stretch as much as C. So the same equation that we used for B is actually going to be tied to C, and then we'll need to change that equation for B, just to make sure that we have this really nice tapering effect as we transform this object, as we start to pull it. And we also have some really nice compression as we start to squash this in. So we'll take care of that, but let's go ahead and stop the lesson here. In the next lesson, we will finish setting up our squash and stretch system.